An AI coding agent can tell you the job is done while the tests are still failing. That sounds like a model problem. Often it is really a loop problem. In the next few minutes, I'll show you what an AI agent is actually doing, 4 ways that process breaks down, and 4 controls you can add before giving it real work. Start with the difference between a workflow and an agent. In a workflow, the path is mostly decided ahead of time. First do this, then that. An agent gets more freedom to choose its own next step and which tool to use. The useful mental model is a feedback loop. Give the agent a goal. It decides on an action. It uses a tool. It observes the result. Then it either updates the plan, finishes, hands the task off, or goes around the loop again. That loop is what makes an agent more useful than a one-shot chatbot. Imagine a coding task. The agent inspects the repository, chooses a file, edits it, runs a test, reads the result, and decides what to do next. The test gives it new evidence from outside the model. If the test fails, the next step can change. That observation is the key. The model is no longer responding only to its own previous words. It has a result from the environment that can confirm the plan, contradict it, or reveal a problem the original prompt never mentioned. But giving a model a loop does not make the loop reliable. The first problem is weak scope. If the goal is vague, something like improve this app, the agent has to invent the boundary. It can solve a different problem, touch more files than expected, or keep expanding the task. The more access the agent has, the more that missing boundary matters. The second problem is weak evidence. The model can produce a convincing completion message without proving that the outside world changed. Done is a claim. A passing test, a visible diff, a rendered file, or a cited source is evidence. The third problem is weak limits. An agent can retry the same failing action, chase symptoms, or continue spending time and credits without making useful progress. Real agent runtimes expose controls such as maximum turns, because every loop needs a stopping rule. The fourth problem is context overload. Each turn adds instructions, tool results, logs, and decisions to a finite context. As that pile grows, the original goal has to compete for attention. More context is not automatically better context. So before you let an agent run, give the loop 4 controls. First, scope. Define the goal, the boundary, and what done means. Second, evidence. Require an external check that can disagree with the agent. Third, limits. Cap turns, time, budget, retries, and tool permissions according to the risk of the task. Fourth, approval. Pause before destructive, expensive, external, or ambiguous actions so a human can decide whether the loop should continue. Now the system is not just goal, action, repeat. It is goal plus boundaries, act, observe, verify, and then stop, ask, or continue. None of this makes an agent infallible. The model still matters. The tools still matter. The environment still matters. But a better agent is not just a smarter model. It is a better controlled loop. Next, we'll turn that loop into an actual agentic engineering workflow and show why one giant prompt is not the answer.